determine the rate of change of one variable with respect to another. An application is involving rates of change occur in a wide variety of fields. A few examples are population growth rate, absorption rate, water flow rate, velocity, and acceleration. These are all derivative questions. They're talking about where can you apply. They're giving you examples of where you can apply calculus, in other words. A common use of rate of change is describe the motion of an object moving in a straight line. In such problems, it is customary to use either horizontal or vertical lines that designate origin to represent the line of motion. On such lines, movement to the right or upward is considered to be what? Positive direction. So if you go upward or go to the right, that's a positive. And if you move to the left or downward, it's considered to be what? Negative direction. So is everybody with me? Go up, right is a positive. Go down, what to left is what? Negative. Just like a coordinate system. Negative is a left, right is a positive. The function S that gives a position relative to the origin of an object as a function of time t is called position function. If over a period of time, a delta t, the object changes its position by amount of delta s, which is s of t, delta t minus s of t. This is like a delta y. Are you with me, class? Remember the changing of direction, distance, they're using a delta s. Delta s stands for changing in distance, okay? This is like f of x plus delta t, and this is what? F of x, they're just changing a variable. Remember, previously we used which one? We used which variable? We used delta y, and then what did you put? F of what? X plus delta x, and then what? Minus, and then what? F of x, that's what we used. Remember that? But now they're just using what? Different letter, but the same meaning. All right, the same meaning, just a different letter. All right, rate is equal to what? Rate, the speed, the rate is equal to distance divided by time. You probably use this one in your physics class all the time, okay? When you find your distance and velocity and acceleration, you use this. All right, average velocity is change in distance divided by what? Change in time, which is delta s divided by what? Delta t. So we just replace what? We used to use x and y, but now we're using what? S and what? T. Is everybody with me? It's the same thing, but we're just using a different variable. We used to use f of x. Now we're using what? S of t. Is everybody with me? The same thing, we're just using what? Different letter. Is everybody with me now? Because sometimes you change a variable, realize you get confused, but nothing to be confused, right? Because now I'm not using f, but I'm using a what? S. I'm not using x, but I'm using what? T, because it's a what? Reality problem. Time is a t. The distance we use what? S. So you can literally see it's an application problem. All right, a variable drop. I cannot say this word. I don't know why. I was just gonna say ball. Okay, the ball is dropped from a height of 100 feet. The ball's height s at time t is a position function. X is equal to negative 16t squared plus 100. That is your position function. Where s is measured in feet and t is measured in seconds, find the average velocity over each of the following time intervals. They gave you two intervals. This is time. First time, this is what? End time, right? This is just starting time, this is end time. They're giving you different examples. Let's do it. So first time I'm plugging t equal to 1. So negative 16 times 1 squared plus 100 give you what? 84 feet. Okay, second one. So this is your starting time. So now my ending time. Time equal to 2. So s of 2 equal to negative 16. 2 squared plus 100 give you what? 36. So now average velocity is what then? Changing distance divided by changing time. So I have 36 minus what? 84 divided by what? 2 minus 1 give you this. So negative 48. So what does that mean then? Which way is it moving? Moving down. For the interval 1, the starting time is 1, and I travel what? Half second, which is 1.5. The object falls from the height of 84 feet to a height of, then I'm going to do 1.5. Okay, I'm not going to do 1 because I already know what that is, right? Remember when f, the s over 1, that's what? 84. We already have done it from previous problem, so I'm not going to do it again. So I'm just going to calculate when t equals to 1.5. What does it give you? 64. So I'm going to do exactly the same thing again. 64 minus 84 divided by what? 1.5 second minus 1 second gives me this. So now where is now? Average velocity is what? Negative 40 feet per second. Okay, next it's the same thing again, right? So you understand what to do, right? All right, next one. So note that average velocity are negative, indicating that the object is moving what? Downward, just like we talked about it before. Okay, in general, if S is a position function for object moving along a straight line, the velocity of object at time t is what? Velocity is equal to what? Taking a derivative of S function. This is your what? Definition of what? Derivative. By limit process. So velocity is the same as what? Taking a derivative of position function. Just like this, I said f of x. If I take a derivative, what do you get? F prime of x. But now we have a special name. This is what? Position function. What do you call this? Velocity function. Same thing. Does it make sense to you guys? Okay. The other word, the velocity function is derivative of a position function. Velocity can be negative, 0, or what? Positive. So if it's negative means what? Going left or going down. 0 means what? It does not move, right? It's a horizontal line, that's right. What does this mean? Going upward or what? Going to the right. Okay. The speed of object is absolute value of its velocity. Speed cannot be negative. Are you with me, class? In other words, velocity can be negative, 0, or positive. But if you're talking about specifically talking about speed, speed cannot be what? Negative. You can have a 0 speed, you can have a positive speed, but you cannot have a what? Negative speed. Position of a free-falling object. This is a free-falling object, okay? It's a free-falling, coming down. Neglecting air resistance. Under the influence of gravity can be represented by equation. S of t equal to negative 1/2 gt squared plus what? V naught t plus what? S naught. So, okay, write this down. This is free falling, which you use this in your physics class all the time. So, where S0 is what? Initial height. And what is this one? Initial what? Velocity of object. So usually they provide you that. Look at your homework problem, they tell you what your initial velocity is, what your initial height is. So it's given to you. All right, on Earth, the value of g is approximately what? 32 feet per second, or what? 9.8 meters per second. So in other words, you have what? 32 feet per second, and second means what? Second square, right? Or you can write down as what? 9.8 meter per what? Second and second. All right, second square. You can write it down like that. So that's always true for what? Gravity. Time t equal to 0 seconds. A diver jumps from a platform diving board that is 32 feet above the water. Look at the figure. The initial velocity of a diver is 16 feet per second. When does diver hit the water? That's the first question. What's the second one? what is diver's velocity at impact. So I want to know when does diver what? Hit the water, so I need to know time. What is this time? What else I want to know? I need to know velocity at this time. That's what I want to know. Is everybody with me? So far so good? Yes. St is equal to -1/2 t square plus v0 t plus what? S0. So that's your given, and we gotta figure out what to plug in the numbers that we don't know, right? T is fine, because that's the one we're gonna figure out. But the problem has to provide me what this is and what that is. Are you with me, class? So you tell me, what is it then? Okay, we know what this is, right? That's supposed to be equal to what? 32. Why am I using 32? Because the problem says what? 16 feet per second. What is this one they're giving you? This is what? V0, does everybody agree? Because it says what? The initial velocity of a diver is what? 16 per second. So can I plug in this as what? 16? What else do you know? What is my initial height? 32, because it says from here to is what? 32. So I can change that into what? 32. So what is my new equation that I can use? S of t is equal to what? -16 t squared plus 16t plus what? 32. Is everybody with me? Okay, they don't give you equation, but you have to make equation because you know what is general equation is. Using this general equation, you plug in what? Whatever is the one that they gave you as your what? Part of the problem. So far, so good? So, does everybody understand this on how we got this? So far, so good? Okay. All right. So we got that. Class, let's look at this problem. Can I factor this?
Yes.
Yes. What's my common factor?
16.
Okay, 16. Can I take it out -16, class? Because I like to have a positive inside the negative, so can I take it out -16? Is that okay with you guys? All right. If I take it out negative, then this become a what? T squared. This become a what? Minus t. What's this become? Minus 2. Is everybody with me? Right? This is the same as -16 times 1. This is the same as what? -16 times what? 1. No. -1. What's this one? -16 times what? -2. Is everybody with me? So far, so good? All right. Can I factor this on one more time? What is that equal to? I see t and then what? 1 and 2, but I want 2 to be negative numbers. Everybody with me? Because your middle number is what? Negative. So I will have t plus 1 and then what? T minus 2. The problem says what? I want that to be where? Right here. That means my position is equal to what? 0. Over here is what? 32 feet. But when I come down all the way, what's my height? 0 feet. Is everybody with me? So I can set this equal to what? 0 to figure out my time. Everybody with me now? Okay. So let's finish it then. 16 doesn't matter. 16 you never can be 0. So I can set what? T plus 1 equal to what? 0. Or what? T minus 2 equal to 0.
Subtract 1.
Okay, subtract 1. Can I bring all these things over here? So t plus 1 equal to 0, then t equal to what? -1. Or t minus 2 equal to 0, so t is equal to 2. So which one can I only use and why? Which one is my answer? 2. Only this. 2. So it takes only 2 seconds to come down from where? 32 feet to where? Ground. So diver, it takes him what? 2 seconds to come down over here. So it will show you more actually. They'll give you what we just did, but they skipped the step. Like they didn't tell you how you got this up from here. That's the reason that I did it previous page, so you know how they got from here to where? Here. All right. And then what you do? They're gonna say this, and they say, hey, we only gonna choose what? T equal to 2 because time has to be either 0 or what? Positive number. So we got the first one done. So in other words, taking from here to come down over here, it takes what? Only 2 seconds. That's what. The velocity at time, t is given by the what? Derivative. So let's find, well, they already gave you. What was my equation? You see, let's look at my equation. That was what? 16 t squared plus 16 plus 32. So let's take a derivative. S prime of t, or I can say what? Velocity. Right, class? Velocity means what? Take a derivative of s. So what is my derivative? I do what? 16 times which number? 2 times t to the what? 2 minus 1. What's next one? 16 t. Okay, how about I don't skip any steps so you can see it, what's going on? This is the same as t to the 1, right? So I'll do times 1, t to the 1 minus 1. And everybody know that derivative of constant is what? 0. So everybody following me? We done it yesterday, remember? The power rules and constant rule? I'm applying it right now in a real problem. So that is equal to negative 32t, and this is equal to what? That become a t to the 0, which is equal to what? 1. So 1 times 16 is just simply 16. So does everybody see it? My velocity function is this. Or I can say S prime of t. So they're asking you, what was the question? They said, the diver is at 32 feet. Come down to where? 0 feet. So we know the time. It takes what? 2 seconds to come down. Now let's find the velocity. Then I need to plug it in t as which number? 2. Yeah, let's find the velocity. That gives me negative 32 times 2 plus 16. What is my velocity? Negative 64 plus 16 is 48. What's that mean? It's supposed to be negative, right? Why? I'm coming down, right? Downward. So it's negative 48 feet per second. That's so they were talking about this, which we know.